Hello Year 12 chemists, welcome to TP's Chemistry Cuts. In this clip we're going to carry out some simple calculations of concentrations in solutions and then follow this up by calculating an unknown concentration of a solution using data from a titration.
So, what we're going to do today is we're going to look at the calculations involved in the practical part of this assessment, in the titration. So we're going to look at how we calculate concentrations in solutions. So we're going to start off with some simple examples, and then we're going to extend it like we did with molar mass and converting between mass and moles. We're going to do the same with concentration in moles, and then we're going to do something where we did the equivalent of a mass to mass. We're going to do a concentration to concentration. So in a titration, what you actually do is you start with two solutions, one with a known concentration and one which you're trying to find out the concentration of. And there may be many reasons for that, but a titration involves using accurate measurements of volume which you add together, volumes that you add together, so you know you've just finished the reaction. If you know the concentration of one, you can work out the concentration of the other. So we're going to go through the background of what concentration is, do some simple concentration calculations, and then we'll go on to those calculating the concentration of an unknown. Okay? Now, what are the units of concentration?
Mole per unit. Mole per litre.
Moles per litre. And that in itself tells us how we calculate concentration. So the reason it's measured in moles per litre is because it's telling us, by definition, this is for concentration, that it's telling us the number of moles that are dissolved in each litre of solvent. Okay, so that's what it means. Now I've defined it there in terms of solute and solvent. We'll actually be dealing exclusively with aqueous solutions where our solvent is water. So bear that in mind. You can calculate concentration very, very simply because this is telling us moles per litre is moles divided by litres. When you see anything with a subscript -1 there, so if you think of speed, that's metres per second, well it's metres divided by seconds. Here it's moles divided by the volume. Okay, so and that's an equation that you'll actually be given. So let's highlight it, shall we? Make it fit here and that in. Mole. Okay, so it's moles divided by litres, moles per litre. Okay, so we can rearrange that as well, because we might need to go the other way from this. If we know the amount we're using and we divide it by the volume, that will give us the concentration. We might need to work out the amount given the concentration and the volume. Okay, so so that's the other form that you're going to be using. So let's do a couple of simple calculations. As I say, for every single type of problem like this involving maths, let's see what we've been given. We've been given an amount, okay, so that's, and we've been given a volume. However, we've got to be careful. Where's the first potential banana skin here? It's in mils. And we've said here it needs to be in litres. So what do I need to do? Exactly right. And it's really, really important you remember that. This is one of the things that people, in the stress of a titration, forget. So, I'm going to highlight this. As you correctly say, divide it by 1,000. So, again, show you're working. Okay. Is n, which is 0.0650, divided by 200, and I'm going to write it out in full, but you can write 0.02 if you want, or 0.2 if you want to. And if somebody could calculate that, everybody should have their calculator out. Remember, you're going to be doing... Sorry? 0.325 mole per litre. Okay. Remember, you must get significant figures correct. This one's been quoted to 3 significant figures. It's a nice example of working out significant figures because you've got leading and trailing zeros. Remember, the trailing zeros count, the leading zeros don't. So this is 3 significant figures, and this one, of course, is 3 significant figures, so you must quote to 3 significant figures. In other words, the least accurate measurement were all the same accuracy. And you must put in the units. That's an expectation in years 12 and 13 for excellence. Any calculation must be the right number of significant figures and the correct units quoted. Let's try a slightly different one. This is the sort of things that a lab technician would do, or somebody like an analyst would do, if they were preparing a solution to do a reaction or a titration. Okay? You need to calculate the amount you're going to put into a certain volume because you're going to make up a solution of known concentration. So once again, what we've got is the volume and C. Okay, so I'm going to put the answer thing over here. Show your answer, all the workings, I show the working in your answer. So this time we're going to use this version, the rearranged version of C equals N over V. So N equals C times V, which is 0.246 times 300 divided by 1,000. Somebody could give me that?
0.073. 0.073.
Okay. What I want to do is to take this now and use it as part of a titration calculation. What a titration involves is carrying out a known reaction, and you have some way of knowing when you exactly reach the end point of that reaction. Okay? Called an endpoint. And we use an indicator. We're going to do an acid-base reaction. They're very straightforward. Acid plus base, salt plus water, one of those types of reaction. And we can mark the exact end of that reaction, in other words, when we've added mole equivalents of an acid to a base or a base to an acid, using an indicator. An indicator changes colour right at that end point, very conveniently for us. Okay, so once the indicator just changes colour, we know we're at the end of that reaction. Now, if we have a solution of known concentration, we know exactly what amount of substance, whether it's the acid or the base, we're starting with. Okay? If we've got the exact volume we need to get to the end point of that reaction, we know the number of moles of the, say, the acid. We can equivalence that to the number of moles of the base using the equation we can write for it, because the equation tells us how many moles of acid reacts with how many moles of base. So if we know how many moles of acid we've got, we can work out how many moles of base we've got. Once we've got the volume to get to that exact equivalence point, or sorry, that exact end point, then we can work out the amount. So we've got the amount and we've got the volume, we can calculate the concentration of that solution. So we can use a solution of known concentration with a known type of reaction with a known mole ratio of reactants to work out the concentration of an unknown. Now, what I'll do is I will put what you'll get on your paper, and that is C equals N over V here. Okay, because that's what you're given. Remember, if you want to work out N, it's C times V. So, I would suggest that you actually transfer this onto your, because you'll be given this on a piece of supplementary paper. Put this onto the main sheet and put the rearranged version, N equals CV in pencil, next to it. Okay? As I said, for the mass-to-mass calculations, it's a good idea to put what your known and your unknown is and the values associated with it. Okay? So, I'm going to do that as a table.
Sir,
So our known is HCl. Our unknown, therefore, is NaOH. Don't do anything like molar masses because we're not doing calculations of masses. We need the concentration, which is, and the volumes. Okay. So we've got 13.5 mole per litre. 13.5 mils of HCl, so 13.5 of HCl, and we know it's going to be 0.0565. Well, we don't know what NaOH is, that's what the first part of the sentence tells you, okay, but we've used 25.0 mils. I would actually put this in litres, to save you the grief later on of making any mistake. Okay? And it really is important you do this. I strongly recommend you doing this. It takes a little bit of extra time, but you won't regret it when you're coming to do the calculation. Okay? Now, I'm going to lay out the calculation exactly as I did the mass-to-mass one. You'll find that the internal assessment sheet will set it out more or less the same, but it will guide you through the steps. I'm just going to get it so you understand what the steps are well in advance, so you know exactly what to do. Okay? So, the very first thing, you could be able to tell me, what's going to be the first thing I need? Exactly right, equation. I need an equation, a chemical reaction, which is going to give me the ratio of moles of the two reactants for the known reaction. And we know that to be, so let's start with our E. Remember, it's the same steps as before. So we're going to start with our equation, which is NaOH and HCl going to NaCl plus H2O. Now, the only thing we're interested in this equation, it's a known reaction, okay? We're not interested in trying to work out masses or anything. We just need to know what ratio of moles is reacting. And this is a nice simple one for the simple reason that this is a 1-to-1. So if we know the number of moles of one of the reactants, it's the same as the number of moles of the other, because it's a 1-to-1 reaction. Okay? So the next thing we need to do is what? I've more or less given it away, because we've got the equation here, which is telling us the ratio of moles, so what do we need to do? The known. Yeah, so we've got to work out the number of moles of the known substance. And that's for HCl, so let's do that. So it's K, which is for the known. Now you don't have to write this all out every single time you do one of these problems, just do each step in turn. Okay? But I'm just stepping you through it now. So we're going to calculate the known amount, and we use that using N equals C times V, which is given over there, because you've written it down at the beginning. Okay, so that's C times V, and if we look at our table, that is 0.0565. 565 times 13.5 over 1,000. And this is the step where it's so important you do your table first. We get at least a couple of students every year that get the volumes the wrong way round. So if you carefully put your table together, you can just do your column. Can somebody quickly calculate that for me? Trevor's sort of catching me up. 7.63 times 10 to the minus 4 mole. Okay? Now, whatever number you've got, so whatever number you've got on your calculator, leave that. Do not round it on your calculator. So don't round it and then put it back in. Leave it as it is. Okay? Otherwise you're going to be compounding errors all the way through.
Wait, so it's rounded.
Yeah.
It is wrong.
I give you the rounded number.
That's okay. You can write up the rounded number, but keep the unrounded number on your calculator. Right. The next thing is we're going to relate the known amount, because we've got an amount now, we're going to relate that to the unknown. And we're saying if we've got one of these, okay, then I need one of those. So if I've got 7.63 times 10 to the minus 4 of those sodium hydroxide, I need the same here. So it's just a one-to-one reaction. Okay, so I'm going to write that.
Shouldn't
so
that be to the power negative 3?
Is it 3?
Yeah, I'm pretty sure.
No, it's 13.5 divided by 1,000, which is 0.0.
Oh, okay.
You can see now why I'm saying everybody should be using their calculator. Because this is what happens when you all do it, but eventually you'll start being consistent because you're all getting good practice. So you should all do this. Yes? Okay, so we're doing the relating known to the unknown by mole ratios. So we know that this is a one-to-one reaction. I don't know why I wrote that out. Okay. So now I've got the amount of the unknown substance. I have the volume for that unknown substance already, because that's what I measured during the experiment. That's the whole point of the titration, is to measure that. And so I can now calculate the concentration. Okay, so red. So I've got my amount there. And then back to our table to make sure we get the right volume. Our unknown is sodium hydroxide. The volume I've used is 25 over 1,000. And 0.0305 mole per litre. And this is or all the numbers here, this is the three significant figures, that's the three significant figures, that's the three significant figures, so my answer needs to be to three significant figures, and you need to actually show me, because I'm an idiot and I'm marking your paper, so you need to tell me that's three significant figures. Okay, and so that's your S.